Hey, what's going on? It's Justin Dickmeyer from engineerintrainingexam.com, and in this video we will reinforce your understanding of the dot product. Now the dot product is one of two operations derived from the multiplication of two vectors. So assuming we have two vectors, say A and B, and these vectors have the components A1, A2, and A3, and vector B has B1, B2, and B3. Now the dot product, which is notated as A dot B, is equal to A1 times B1 plus A2 times B2 plus A3 times B3. So this is the dot product of two vectors. So let's look at an example of how we can use this equation of the dot product, or this formula, to determine the dot product of two vectors. Let's say we're given vector A, which has the components 0, 3, negative 7, and we have vector B, which is defined 2, 3, and 1. So the dot product of both of these two vectors would be 0 times 2 plus 3 times 3 plus negative 7 times 1, which equals 2. So as you can see, the result of a dot product is a scalar. It's a single number. So remember that. Now the dot product can be geometrically interpreted as well. Say we have two vectors, A and B, and that the A and B has a specific angle between it, theta. So assuming that theta is somewhere between 0 and pi, the dot product can be written as A dot B is equal to the magnitude of A times the magnitude of B times cosine of theta. So this is the geometric representation of the dot product. Now we can also use this formula along with our traditional formula to find the angle between two vectors. So let's take a look at a quick example of how we can use that. Let's say that we want to determine the angle between the vector A, which is 3, negative 4, and negative 1, and vector B, which is 0, 5, and 2. So looking at our formula here, we're looking for theta. So we obviously need to find the dot product from our traditional formula. We need to find the magnitude of A, and we need to find the magnitude of B before we can determine theta. So A dot B is going to be 3 times 0 plus minus 4 times 5 plus negative 1 times 2, which gives us a scalar value of negative 22. Now the magnitude of A and B are square root of 26 and the square root of 29. Now I'll let you guys determine how I came up with that. That's just basic geometry, but just wanted to speed this review up because I'm sure you don't want me to waste your time with that. So now that we have all this information, we can just simply plug it into our formula here. Rearranging cosine theta is equal to A dot B divided by the magnitude of A times the magnitude of B, which is negative 22 divided by the square root of 26 times the square root of 29, which is equal to negative 0.801. Now taking the inverse cosine to get our final answer of theta, and that will be equal to 143.2 degrees. So that's how we determine the angle between two given vectors using our dot product and geometric interpretation of it. Now there are a number of general applications that we will need to knowledge of the dot product to complete. One being the application known as projections. Projections. So to illustrate a projection, say we are given two vectors A and B, and that we want to determine the projection of B onto A, denoted as the projection of B onto A. Now the projection is simply, all we do is draw a straight line that's 90 degrees to this vector A here, and this little new vector that we have is the projection of B onto A. Now the formula for finding this projection is A dot B divided by the magnitude of A squared times the vector A. Now it's important to note that the projection of A onto B will not be the same formula. The formula is generally the same, but is written like this. So the projection of A onto B is equal to A dot B divided by the magnitude of B squared times B. So notice we're going to get a vector output. We're looking for a new vector. Once again, this is the projection of B. Drop it straight down so the line makes a 90-degree angle with A, and this new segment right here is the projection, in this case, of B onto A. So let's look at an example here, how to find a projection. Let's say that we're given two vectors A, and that's defined 1, 0, negative 2, and we have a vector B, which is defined 2, 1, and negative 1. And we want to determine the projection of B onto A. So visualize this right here. We're looking for B onto A. So once again, our general formula is right here. This is our general formula. So we know that we need the dot product, we need the magnitude of A, and we also need the definition of A, what the vector is. So the dot product is A dot B is equal to 4. And I'll let you guys figure that one out just so you guys can confirm that you understand that. And the magnitude of A squared is equal to 5. So plugging this information into our equation, we find that the projection of B onto A is equal to 4/5, 1, 0, negative 2. So we find that that new vector is 4/5, 0, negative 8/5. So that would be our projection of B onto A. Let's finish this off by talking directional cosines. Now this is another application where we need the knowledge of the dot product to determine the output or the directional cosine. So let's say that we have a vector A, and this vector is in 3D. Let's see if I can draw a 3D for you guys so it's not too terrible. We got axis Y, Z, and X, and that we have this angle defined as beta. We have this angle defined as epsilon, and this angle right here, alpha. So we have three defined angles, and we have a defined vector A. Now this vector forms angles, like I said, with the X, Y, and Z axis. These angles are called directional angles, and the cosines of these angles are called directional cosines. So the general formulas which we use to determine these directional cosines are this. Cosine of alpha is equal to the dot a dot I over a, and this is also equal to a1 over the magnitude of a, and cosine of beta is equal to a dot j divided by the magnitude of a, which is a2 over the magnitude of a, and finally cosine of epsilon, which is a dot k over the magnitude of a, which is equal to a3 over a. Now these are the components of the vector a1, a2, and a3. So actually I can take away these, ignore these vector signs here. So that's a1, a2, and a3. These are our general formulas for the directional cosines. All right. So let's just determine real quickly one of the, let's look at an example and just find one of the directional cosines. Let's say we're given given a vector A that originates at the origin, and it's defined 2, 1, negative 4. And we want to determine the directional angles and the directional cosines. So let's first define the magnitude of A, which is going to be the square root of 4 plus 1 plus 16, which is equal to the square root of 21. Now the directional cosine, let's just look at alpha. Let's figure out what alpha would be. That would be cosine of alpha is equal to 2 divided by the square root of 21. So we took this first component and divided it by the magnitude of A, which, as you can see right here, is our general formula. And that's all it takes. All we need to do now is take 1 and divide that by the square root of 21, find the directional cosine beta, and do the same for epsilon, and that's all we got to do. So that's it, guys. That's all there is to the dot product. I kind of ran quickly through that review, but I hope you guys picked up on some knowledge that you already had. Just head on over to my site now at engineeringtrainingexam.com and shoot me an email, give me some feedback, let me know how I'm doing, and also shoot me any suggestions if you have any. Certainly here to help you, and that's why I do these videos. So for now, we'll be talking soon. Take care. Bye.